Welcome tonight to Session 12, Developmental Software. We're really pleased tonight to present three different views of developmental software, software that we think will really make a difference in the future of computing. First tonight, we'll be talking to Miles Dempsey and seeing a piece of software that his company developed, Protoview Development Corporation. This software is software that really writes in C code or Pascal. It's software that can really make a difference in decreasing the kind of time that you need when you really want a development job and need to get it done quickly. Secondly, tonight we're going to be talking with Aly Monsour, who has developed a decision support system that can actually predict, before a person enters a university as an undergraduate, whether or not that person will succeed in the first year. And thirdly, we have an excellent multimedia demonstration from Insync Corporation. And Bob Shea is going to be talking and showing us a tool, a multimedia tool developed that will really help those who need to learn about total quality management. We're really fortunate in being able to present these three packages. Right now, what I'd like us to do is to look at the kind of development of Protoview Development Corporation software, which we think will make a difference in facilitating the whole software process. Organizations and agencies, both in the public and private sectors, are faced with the problems of increased technology demands. What we're finding is that more and more customized programming has to be carried out in order to meet these demands. We're very fortunate today to be able to have with us Miles Dempsey from Protoview Development Corporation, who's going to be talking about a development tool that will help these organizations and agencies in both public and private sector really increase their capacity to do customized programming, at the same time decreasing both the cost and the amount of time necessary to make this customized programming happen in a very efficient way. Of course, the key is always, will this all increase productivity and decrease cost? Miles, why don't you tell us a little bit about the underlying idea of Protoview Development Corporation and about some of the concepts and thinking that you have put into this whole development process and how it can help organizations and agencies.
Okay, Reynolds. Protoview was founded in 1988, and the goal of Protoview at the time was to provide client-server development tools so that we could begin to provide to industry, both government sectors, private sector, educational sector, necessary tools so they could build their mission-critical applications in order to provide graphical user interfaces on the front end with relational databases on the back end so that they could put together the applications which would facilitate different business logics, different application needs, and they needed to be able to do it in a very timely manner. And so what we did is we set out to begin to pioneer what we call visual development tools. And these tools enable programmers that at one time had to use editors and clunky programming techniques to use very intuitive point and click, drag and drop techniques in environments like Microsoft Windows so they can program the applications much quicker with less training involved in getting the programmers up to speed, and the overall development cycle is really reduced by magnitudes. They can take our tools and develop applications in months, what used to take several years to develop.
So you can really enormously decrease costs because programming has become such an expensive part of industrial development.
That is true. If you take a typical shop that has maybe 10 programmers on a project, you take that shop that might have taken 2 years to put together applications on the mainframes, programming in languages like COBOL. You can take that same group of people, we can train them in probably 2 weeks, and we can make those people productive and building applications in 2 to 3 months. And so the overall cost of the product cycle goes down because the time involved has decreased dramatically, and the tools then are flexible enough so that they allow those particular programmers to modify the applications they begin to build. So from a maintenance point of view also, we've decreased the cost because when the business logic changes and the corporation moves forward and they need to make modifications or enhancements to their programs, it's much easier to go in with visual development tools running on these very inexpensive microprocessors and make those changes so that the cost involved is dramatically decreased.
Could you cover some of the underlying concepts and definitions and things that we need to understand as you go on with your explanation, give us examples and discuss your tool?
Yes, that's what I'd like to do. Several of the ideas that we incorporate into our product is the ideas of the client-server model. We like to incorporate the graphical user interface, the relational data model. The overall goal is to be able to visually program. And then what I'd like to do is share with you an example that we have done in the last couple of years with an organization in Philadelphia, Conrail Consolidated Rail Corporation.
That's great. Well, why don't you start off by then talking about the client-server model and some of the things we need to understand within that.
Sure. What has happened in today's society in the information technology infrastructure is with the advent of the personal computer, people begin to downsize or right size.
Mm-hmm.
What's happened is organizations find that they can go out and spend a fraction of the dollars, buy personal computers, network them together, and put together a hardware topology and software topology that will allow them to facilitate their business needs without paying the millions of dollars involved with the hardware of mainframes and then also with the programmers to program mainframes. So what the client-server model is it's PCs networked together with client PCs running on desktops so that workers in the organization can each have their own personal computer, and then PCs serving as dedicated servers that will hold things like the relational databases, the multitasking operating systems that will allow us to share resources such as printers and,
Mm-hmm.
and different kinds of other hardwares that's critical to that organization.
So in this new topology, the key factor is that it's downscaling or making sure that it meets the exact requirements, and your software development piece is something that fits specifically into helping them do their front-end programming.
That's exactly right. The key is that either organizations can downsize, which means that they take the client-server model, which is a combination of PCs, and totally replace mainframe processing, or they can take the PCs and make the client-server model adjunct to the mainframe, where they're not necessarily eliminating the mainframe, they're using it in a different role. What our tool is it's a tool that allows them to build applications that run on the client side of the client-server model and also access the data that are on these PC servers, and also in the right sizing situation we can access the data that's on the mainframes.
Okay. Go ahead. Well, please go on.
Okay. What I'd like to do is I'd like to give an example of the client-server model from a graphic point of view. Okay. Typically, organizations, when they begin to build their applications, they want to think about what's called the presentation layer. The presentation layer is the layer that the end user is going to interact with. We typically call this a graphical user interface today, and it is the layer that your purchase order agents or your inventory managers are going to use day to day in their job functions. Okay. Behind that presentation layer is what's the business logic. And the business logic is what the programmers have put together in order to facilitate mission critical needs. If you were dealing with a train company like Conrail, the business logic might be putting together a waybill so that cargoes can be put on the trains and then they can be charged out accordingly. If you're dealing with a airline, the business logic may be the processing of tickets for customers so they can get from one destination to the next.
And is what they see when they're doing their work, is that what your tool develops, or does it go beyond developing this graphical user interface?
Our tool goes beyond the presentation layer and also the business logic, because what we've done is we put together a client-server suite which allows us to actually access the data on what we call the back end, or the server. So with our product, we can implement the presentation layer, the business logic, and also the data management from the point of view that we visually can access the data that goes into the servers, whether they're on PCs or whether those servers might be mainframes.
Well, let's go on.
Okay, let me bring up another slide. Just as an example, I'd like to show a slide where we have a PC client that may be 386 SX based, and that particular PC may be networked into another PC, a server, and it might use the new Pentium chip from Intel Corporation. Okay. Typical hardware topologies that you would find out in organizations might be token ring or Ethernet. This example in this slide demonstrates that with an Ethernet connection, we can hook these two PCs together. Now, once you have the hardware topology in place, you got to make a decision of what kind of software you want to run on different PCs. If it's the client, you typically might want to run the Windows 3.1 environment.
Exactly.
And the Windows 3.1 environment will allow us to run graphical user interface applications that are put together by our tool. On the server side of things, you might want to run the Windows New Technology, or NT, operating system. This is a multitasking operating system which will allow us to run the software that acts as a traffic cop to the network. It allows us to run software that can share different resources such as printers, and then it also allows us to run the software which is the SQL relational database software.
Can you write, using Protoview, your software so that it will run in all those three environments?
That is correct. Our software will enable you to build client applications to run on the PC side, and at the same time access the data that may sit on the server, not only from a PC point of view, but also a mainframe point of view. So this particular slide was just an example for the audience to understand what a typical configuration out in corporate America may look like. Mm-hmm. Okay. What I'd like to do is point out really some of the advantages of the client-server model. Okay. The goal behind the client-server model is to be able to deliver applications very fast. With the tools that we have today, those applications can be delivered fast. Our visual programming techniques allow us to do the same applications in 2 to 3 months that used to take probably 2 years, maybe 3 years. Okay? With the client-server model, new sources of information can be added very quickly. Because we're in a network topology, we can take another server with another relational database that contains new information that a company may be tracking about sales or about possible new clients, or even R&D information that may be on a new product line they're bringing out. And those servers can be added to the client-server network, and applications that were written very quickly can now access that particular data. Okay? Another big advantage of the client-server model is that new technology can be added very quickly. If you have a server that was, say, 486 based in the past 6 months and you needed to upgrade, well, all you would need to do is pop out the 486 chip and place in a new Pentium chip, and nothing has changed. You've just added processing power that's going to allow your organization to retrieve their data much quicker than they did in the past. Access to important data may have been easier than ever. Now with the PC network, you can have people that are in research and development access data that's in marketing, or you can have sales access data that's in the production factories and so forth. So what this whole thing does, it provides new business opportunities. Organizations have information at their fingertips that they can utilize in order to put together new strategies so that they can evolve as we move along in this new business frontier.
Sounds like it's something that we really need to take carefully into consideration as we carry out any kind of development. What are some of the other definitions that we need to really look at, or overall concepts? Okay,
let me go to one last slide on the client server, and then we'll do that. One of the things that I wanted to point out about the client server model was that it's relatively inexpensive compared to the mainframes of yesteryear. It's easily scalable. That is, we can add many PCs to a network. It offers distributed computing from the standpoint that an individual can access the data across locations. One of the major technical parts of the client-server model is it reduces network traffic. In the past, whenever you had a mainframe situation and you had dumb terminals, operators at dumb terminals would request information off the mainframe, and what would happen is many pieces of information would have to come back in order to process that particular query, so to speak.
Right.
With the client-server model, the PC has its own microprocessor and the client machine, and the server has its own microprocessor, each of which can carry out duties that no longer have to go across the network. And then finally, the model can be redefined very quickly. That is, in a nutshell, the client-server model and some of the goals. The graphical user interface has emerged as one of the most popular platforms on today's personal computers. The latest figures put Microsoft Windows 3.1 at about 40 million in overall sales. There's about 200 million PCs around the world today, and so the general trend is to move to the graphical user interface. What I'm showing here is an actual picture of our product, ProtoGen Plus. Let's take a look at that. Okay. What we have is a window, i.e. from the Microsoft Windows environment. We're showing the caption here. We're showing a menu. We're showing right here what we call toolbars or speed bars, and these have buttons, and what these buttons allow you to do is to access functionality and commands very rapidly.
Okay.
Now, in the interior of this window is the actual application that the developer would be building.
Okay.
So our application houses the application in question. So this would be the caption bar for the application.
So it's done directly within Windows.
That's true. And then we have our menu bar that we would be building, and then the speed bar or toolbar for the developer. And then he has his status line, and then of course our status line. So you see, by being in a Windows environment, we can present a lot of information in a very intuitive fashion.
Using icons rather than having to type in directions and commands.
That's exactly right. By being in the Windows environment, the programmer has a visual approach, which is very intuitive, and we've encapsulated many lines of functionality into libraries that are utilized by clicking on various icons and so forth. Let me bring up this slide. The power of the graphical user interface is that it communicates more information than ever. The cliche that a picture is worth 1,000 words holds very true in this environment. The graphical user interface provides a very consistent appearance. 6, 8, 10 years ago, when PCs first started emerging, DOS applications came in many shapes and forms.
Yes.
One set of keystrokes in one application did not do the same thing in another application. The beauty of the graphical user interface set forth by Microsoft, and particularly Microsoft Windows 3.1, is that all the menus, buttons, the list boxes, and various components that make up the Windows environment work the same across any application that's developed by anybody in any part of the country or any part of the world. It's the idea that if you can drive an automobile with the steering wheel, then you're not going to have much problem going to, say, the golf course and driving a golf cart. The general idea is the same. So any applications that are developed by any programmer will be able to be utilized by end users. And that's key, because what happens is the end users will use these products in universities, or they'll use these products on the job. And if they were to get transferred, or if they were to be promoted to another job that required a different type of program, they would still have the general feel of how the application would work, even though the business logic may be a little bit different.
Well, I like also the other 2 points that you mentioned here, which is it reduces training time that we talked about for the end users. And it also provides multitasking environment, which is really also important. And these are the multitasking is the environment that everybody seems to be moving into.
That's true.
And reducing training time is the key, because training is a very, very expensive proposition.
That's correct.
And once you train them in the use of Protoview, then you don't have to retrain them. They're trained.
That's correct. They learn Protoview, and the very fact that Protoview is a Windows application means that if they've learned a word processor, if they've learned a spreadsheet package, they could easily pick up our product and begin to use it to build applications. Okay. Next topic I'd like to talk about is the relational data model.
Okay.
This is the concept that really resides on the back end, or the server side of the client-server model. There's been a couple of models that have been put forth in the last 20 to 30 years, but the model that seems to be catching on the most is the relational model. And simply what that is it's a way of storing information in tables so that application programmers can utilize that data out of the tables and quickly present information to end users in really any form they want. The slide that I'm showing here is an example of what somebody in an organization might want to try to do. Given a customer info table, given a table that contains spending patterns for people, giving a table that has the product lines of the organization, application programmers could put together an application that would really allow an end user to ask the questions, well, if I take this information from all three tables, join it together, I could put together a prospective customer list. So what that will allow them to do is to make mailings into certain segments. For example, if a bank had a relational database, they might want to do some specialized target mailing. They could ask the question, let me see in a query all the individuals that are male that live in the state of Florida that are over 50 years old and make over $50,000 a year. Mm-hmm. They might want to do a particular mailing for a new CD that they might be offering, and they don't want to waste a lot of money just mailing it to all the citizens of Florida, where they know statistically that a certain type of profile individual would respond to that particular offering more so. So this really helps them because they can make these kinds of queries out of a relational data model and get critical information back to meet their business needs.
Let's go on.
Okay. Before we get into our product, we have to talk about the concept of visual programming.
All right.
Okay. Visual programming is the idea that with icons and bitmaps and the mouse, drag and drop, point and click, all these things that have become really mainstream in today's society on PCs, these same ideas that you utilize when you do word processing in a graphical user interface, you can now do to program your applications. That's what we've tried to encapsulate as a company, is the ability to let programmers use a very intuitive visual programming environment so that they can eliminate the need to write hundreds and hundreds and even thousands of lines of code. Okay. On my particular graphic I'd like to show is a couple of the products that we're going to be looking at today.
Please.
The ProtoGen Plus product is essentially the workhorse. It's the workbench and it's the hub and the core of our product. What it does is it's responsible for putting together the presentation layer and also parts of the business logic that we talked about earlier. We have another product that snaps in because the entire product line is very modular, and that's known as the view paint. And the view paint is what is known as a dialogue editor. A dialogue editor is an animal that will allow you to build dialog boxes which are part of the Windows environment. Dialog boxes are essentially screens that are presented to the user that collect information. These are the things that people type purchase orders into, or they type in reservations if you're going to go on an airline. And what ViewPaint really also facilitates is the presentation layer. Okay?
I know that developing the graphical user interface of screens is a very complex process to go through, and requires a tremendous amount of code in order to put everything the way you want it. Does Protoview take care of that programming?
Protoview does that, that's correct. It's very tedious to put together a user interface.
Yes.
5 years ago, if you were writing DOS applications, it could take a year, 2 years just to put together the code to make the data presentable to the end user.
Right.
What our tool does, it really brings that process down to a couple of weeks. And we're going to actually talk about a case study where an organization spent just a few weeks and put together their entire application prototype visually with all of their dialog boxes, all of their menus, all of their graphics and bitmaps. It's a technique which basically takes the mundane process of putting together the interface out of the developer's hand. Okay. We handle that, okay? Because Windows and a graphical user interfaces have the consistent appearance, it's enabled us to basically put together in libraries lots of routines that can be accessed very quickly. So now the programmer concentrates not on the user interface, but the programmer concentrates on his particular business logic. We will handle all of his interface components.
It certainly facilitates the process of development, doesn't it?
Oh yeah, development very quickly. We call it rapid application development.
Great.
And then finally, on the visual programming point of view, is the SQL View product, which is going to be the conduit to the data that resides on the relational databases, okay, or either on mainframes if we want to get data, say, off of an IBM mainframe in DB2 format or a variety of the formats that IBM has come up with. So it's not only enough to put together your front end or your client application, but you need to be able to bring the data back and forth. And we visually can do that also.
Okay, let's go on.
Okay. Visual programming. I just wanted to put out here a few bullets. It's very productive and it's an intuitive approach. Okay. It allows for very rapid application development. By using a mouse, you have the point and click, drag and drop capabilities. It easily facilitates the involvement of many people in the organization, managers, planners, people that understand the application logic, people that understand the business logic, all can participate in the design and delivery of the final application because it's a very intuitive tool. And our tool has been set up to be on PCs so that work groups can use the tool, so that it's just not a one person doing one part of the project. It's many people on the network working on the project at one time. And then finally, what our tool allows us to do is it allows us to take an application prototype that's put together by many individuals and evolve that to the final application. In the past, products like ours, what they did is they allowed you to get a start. You could jump start your application by prototyping it, and once your prototype was finished, you had to pretty much put the tool up on the shelf and then take over by hand and write thousands of lines of code. We've come up with a technology known as regeneration technology, which essentially allows a programmer to insert critical business functionality into the application code that gets generated, and then if he needs to make a change, he can go back into the visual part of the product, make the changes, generate more source code that will facilitate the application without destroying any code that he might have already added. And that's one of the key technologies that's part of our product, is that we become a work-in-process tool from start to finish. The application prototype actually evolves to the final application. One of the first questions that Conrail had to ask or satisfy was, as an organization, did it make sense to build the client-server application? And for them, it did make sense. Okay, let's answer why it made sense. Okay, Conrail agents could use a more intuitive tool for doing their jobs. The goal of the Conrail agent is to put together things that are called waybills, which are essentially, it's like an invoice for the railroad. Sure. They can build these waybills so they can charge out what it's going to cost a particular customer to carry a certain cargo from point A to point B. It's a massive amount of information because there's cargoes comes in all different shapes, sizes, forms, and the rules and regulations that govern the pricing of those cargoes really dates back to the 1800s. There's still those kinds of business rules that exist. And over the last 150 years or so, many, many more rules have been added, and it's really made for a massive amount of information just to come up with a waybill. So the agents were were essentially being overwhelmed with paperwork. With using a Microsoft Windows environment application, they could easily assimilate and put together the waybills. So it was very important for them to get to a client-server model. Because with the magnitude of information, it was doing things like slowing down the network, which we discussed earlier. When they were in a mainframe situation, so much information was being processed that the overall response to create the waybill was really running into minutes. With the client-server model, we could take that same process and really decrease it and create waybills that might be done in 5 to 10 seconds. Okay. Another thing that was very important for the Conrail group was to basically provide a lot of data to the end user through the use of multiple windows. Okay, so that by being in a graphical user interface, they could look at several waybills at one time, or they could go back and look at a historical waybill. They could pull information back from, say, 6 months earlier and compare that information in a window that side by side with a current waybill that they might be creating. So the general goal for Conrail was, do we want a client-server application? And the answer is yes, because of the offloading the processing, decreasing traffic across the network, providing lots of data through a variety of windows that can be shown on the screen at one time. Hence the multitasking environment. Okay. The next thing that Conrail had to do was they had to choose a particular tool that was going to help them build a client-server application. And what they chose was the ProtoGen Plus tool, which comes from Protoview Corporation. Okay. Now, why exactly did they choose that tool? Well, let's talk about that. Okay. Conrail basically wanted to build a client-server application that utilized Microsoft Windows on the client. Now, there's a variety of environments that can run on clients that are in the client-server model. Microsoft Windows is just one of them, and it happens to be the most popular, and that's the route that Conrail wanted to take. ProtoGen Plus, our tool, is a product that satisfies those needs in the Microsoft Windows and Microsoft Windows NT environments. So the fact that we run and exist in that environment led them to choose our particular tool. Conrail wanted to visually program. That was extremely important. They'd spent many years designing and building apps the old-fashioned way, and they wanted to really take advantage of new trends and technology so they could visually program. That was an important consideration for them. They also needed a product that could produce what we call industry standard C code, or ANSI C for American National Standards Institute. C code has caught on to be the most popular way of developing Microsoft Windows applications.
Because it runs on multiple platforms.
What you can do is you can take the C code, yes, and port it to different platforms. If today you're running in a DOS environment and you want to take C code, you can import that onto other operating systems.
Well, although Conrail was interested in C, doesn't Protoview actually produce other types of code?
That's correct. One of the most important concepts of our product is the ability to put together an application prototype where you build the entire presentation layer, and then right at the very end you elect the target language. That is, you can build up your entire prototype and then choose whether you want to generate C code, C++ code, or Pascal code, all popular languages used to build graphical user interface client applications.
What happened, Miles, as a result of this development? You say that normally it would have taken a couple of years, and I agree with that. And you said that basically they were able to do it in just a few months. Is that the way it happened?
That's for the most part. What we need to do is look at the next slide, which really asks the question, how did Protoview and ProtoGen help Conrail meet their requirements?
Okay.
One of the most important things was obviously training. Okay. The Protoview Corporation trained 150 Conrail programmers in the techniques and the ways of using a visual programming tool. It is an intuitive process, but anytime you bring in an expert that's been using it for a while and really hash over in a one-week course with these particular programmers, you hash over the different kinds of features and some of the productivity parts of the product, they can be much more efficient with the tool. And so that's what we did. We went in and spent about 3 months training 150 programmers, 12 per class over this particular 3-month period, and we got them up to speed so that really by the time the first set of programmers from the first week had been trained and the last set of programmers had been trained, the first group was already putting out very complex application prototypes. So just in that 2 to 3 month period that we trained, we had individuals up front creating the applications that the individuals at the back end of the course would then come in and begin to do maintenance on.
Let's try to wrap up, if we can, precisely what we've learned that has a major application to what's going to happen in business and industry and education and just about every field and endeavor as a result of the kinds of things that you've learned about when you've put your product together. Can you mention about just 2 or 3 things at this point that you feel would help us to really understand what has taken place here?
What has really taken place is very inexpensive, relatively inexpensive microchip technology from companies like Intel existing on PC platforms has enabled us to process information and data like never before. We have the concepts of information at our fingertips. We present that information in very intuitive presentations with graphical user interfaces. This whole paradigm shift is taking place right now, and corporations and organizations and government, they all right now are making a move to try to eliminate or at best maybe make adjunct these large clunky mainframes of yesteryear into their information technology infrastructures. So what we have is a shift in the information technology infrastructures. The client-server models are coming in where PCs really can provide for businesses their data processing, information technology needs, and tools like ours are making programmers really put applications together in a fraction of the amount of time that it used to take a programmer in the mainframe world, and they can put these applications together for
they also become interactive and involved in the actual process as development. So as a piece of software is written, as a screen comes up, they can interact with that, and without having to go back and to rewrite a lot of code, they can just go in and make the changes together with the whole development team, rather than just to have one programmer continually come back until it was correct, and maybe it would have to be changed anyway.
That's correct.
Isn't that right?
That's right.
Okay. Now let's talk about the cost factor, which I think is really important.
Okay.
If you're talking about 2 years with 150 programmers, and you cut that 2 years down to do the same job in 3 months, the factor of saving is enormous.
Oh, that's correct. It's easily into the 7 figures over the course of a couple of years when you take a standard programmer's type salary. Just the salaries alone in these type of resources is going to be incredible savings over a 2-year process. But more than that, by moving to this environment, you've set it yourself up to be in a model that's not going to be as obsolete as quick as, say, some of the other applications.
One of the tools, Miles, that I understand you used to do all this development for Conrail was the ProtoGen Plus.
That's right, the ProtoGen Plus.
Client-server development tool.
That's correct.
Could we see a short application of this?
Sure, let's do that. Let's direct our attention to the screen. I'd like to show the ProtoGen Plus Client-Server Development Tool.
Okay.
Here's the what's known as the About box. Let's click the OK button, and let's start off with the workbench. Typically what we like to do is we like to choose File, New. We bring up an application. You might type in something. We'll just put in here Demo.
Okay.
And then you have a variety of choices. What I'd like to show is the MDI application. We'll use SQL View, which will allow us to get visual access to the data we talked about on the servers,
Okay.
and initial toolbar and initial status line.
Good.
By simply clicking the OK button, within about 3 seconds, we can create the shell of our application. Right here, I'm going to roll my cursor up and point to the application caption, which we talked about a little bit earlier, and click it, and here's where we might put our caption. So I'll just put in here,
Okay.
Demo. By clicking OK here, we set Demo here, and now I can roll up to our particular toolbar, and I can actually go into what we call interactive test mode.
Okay.
So if you look here at the screen with me, you'll see that we've taken our tool, we've hidden it from view, and we're showing you the application that you're going to have in its final
form.
Final form, exactly
That's
right.
great.
Here we are. Within just a couple of seconds, we have a menu, and if you notice down on the status line, we're presenting messages as we move back and forth across the menu options.
Okay.
We have a toolbar, which is very popular in today's graphical user interface applications, and then we have our status line down here. So right off the bat, we put together a shell. Now what we need to do is we need to move into the creation of a dialog box, which is really the important part of the graphical user interface, presenting a dialog to an individual so he can put in critical information. If I roll up here to my particular toolbar, I can click this icon off of our product, and we bring up View Paint, which is the dialog editor. There's a variety of features with it, but essentially what happens is you start off with a blank dialog box. This is the palette, much like an artist palette, and it presents to you several controls. For example, we can choose a date. We can place a date there. We can choose a money if we want to have a display of currency.
Okay.
We can actually choose what we call a bitmap, and with the bitmap you can actually go in and select an image, and what I'll do is I'll go in and traverse the directory structure on the computer, and I'll look for some bitmaps, and you'll see here we have the display of a bitmap, and we'll just take this bitmap known as cars here. I'll take that bitmap and I'll place it there in reference, and what we can actually do is take a bitmap and turn it into a button, just like we've done on our product. So if I put in here something like Calc, which is the Microsoft Windows calculator, and then click OK, you see we presented the bitmap to you on the screen, and notice how we can move and drag it around. It's displaying some text, but if we would like to, we could eliminate that text down here. I'll just back this out.
Sure.
And we have some features such as stretching, which if we go into the styles of this particular bitmap, we can stretch it. And you see now that the car is taking on this particular size and shape.
So it actually gets larger as using the stretch command.
That's right. And then what we can also do at this point is go into interactive test mode where we simulate what the application is going to do. Remember that I asked this particular bitmap to launch the calculator. So
right.
Now that I'm in interactive test mode, I can click the bitmap, we invert it for you, and then we launch the calculator that comes with the Windows environment.
Oh, that's great.
So what we've done
it pulls it right up, so if I want to use a calculator at that point, it's right there for me. I don't have to pull that up.
That's true. What we've done is we've taken an image known as a bitmap graphic in the Windows environment, and we've turned it into a button, just like a regular push button might be. What we have on this palette over here is really a variety of controls that you can place onto your dialog boxes to really collect information. Simply from list, if you wanted to place out a list here, we could go into what we call our methods of that particular list, and with that methods we could choose to display perhaps a directory listing. Star.star is a DOS command. By choosing star.star, we place out there the list that's currently in that directory. So you see that we're slowly building a dialog box up to collect information visually. And what I'd like to do is I'd like to save this, and I'll just save this as XXX. Sure. We'll save it to the disk file as XXX. And once we have it saved, we can then close out. And now here's one of the critical things about our product is to be able to link things. If I go into Help here, which is a menu choice, and choose on About, then what it will allow me to do is to link functionality. And what I'm going to do is link to that particular dialog box.
Okay.
So I'm going to click OK, and it's going to show me that XXX is a part of the project that we're building. I click OK here, and we've just made our link. So if I choose the dialog, close it down, go back into interactive test mode, we're showing you the shell of the demo we're putting together, and now this particular menu item, the About menu item, has functionality, and there you have it. We've linked up this dialog box. Now, the last part I want to show you is the actual connection to some data out of a relational database. So again, we can choose dialog editor, and what we've done is we've incorporated our techniques into our dialog editor. If you look out here to the right, you'll see a little tiny button that says SQL. That is for the structured query language we talked about.
Right.
By clicking that particular button, we bring up our dialog box, which allows us to select a variety of relational databases, such as DBase or Paradox, Oracle, Informix, Sybase, all the popular databases that are on the market. I'll just choose DBase right now, and then if I hit the Select button, it allows me to select a few tables from DBase, and what I'll choose is perhaps orders here. When I click Orders here, it's going to show me a list of the fields that are in that table that we talked about earlier. I'll choose all those fields, and then I'll click a feature called Snap Table. And what Snap Table does is it auto-creates the dialog box with all the SQL functionality. So by going into interactive test mode, I can now click the button Find All, and what we do for the developer is we actually show you the structured query language statement that gets generated. Here is a development aid. So then I click OK, and now you see data has come back into the dialog. And now I can click Next, and Next, and see, notice that the data is changing as I click Next, order number 4, order number 5. So what we're doing here is in development, we're literally logging onto a database and retrieving information real time.
As you're doing the development.
As you're doing the development, we are literally getting the data and bringing it back.
So you know exactly what data you need.
That's exactly right.
And you know exactly what it's going to look like when you access it.
That's true.
And you can develop the precise reporting format that you want all at the same time.
Exactly right. And we can show the data in a form type of a format like here. Or if we wanted to, we could show the data in perhaps a table format. And I'll do that right quickly. I'll create another dialog, and I'll choose one of our controls, which is known as a matrix control. I'll place it out there. What we need to do is we need to pick some styles of that particular matrix control, maybe some scroll bars, maybe a grid lines, in-place editing, column resizing. Let me choose single record selection, custom headings, maybe some buttons, and let me just enter in the information of which table. And again, I'll go and choose that same orders table, okay? And it shows us the fields that are in that particular table. I'll choose all of them, and then I'll choose include a key here. And when I click OK, what I'm going to do is I'm going to show you that we've now put together visually a matrix. And if I go into interactive test mode, again, the SQL statement is issued, and we show you that as a developer, and that's the switch that can be turned on or off. and then we come back, and here we're looking at data. So the same data that we looked at a minute ago in a form format is now being displayed to you in a matrix format. And we can actually go in and choose perhaps to make that a 6. And actually when we go and choose to move off of that field, we're going to issue the update command, which is part of the structured query language. And I choose OK here, and we're actually going to redisplay the data and now show you that we've made that change, 6.
In summary, what kinds of final things do we need to know about this that lets us realize just how significant this tool is in terms of decreasing the development time, increasing our capacity to be productive, and really decreasing the whole cost?
Basically, the idea is by visually coding, which we've been doing now, we build an application prototype. Once the application prototype is built, we then can come in and we can choose a variety of standard languages on the market. If you look into this list right here, you'll see we have something called ANSI C, which we talked about. That's what Conrail uses. We have what's called Microsoft Foundation Classes 2.5. We have the Object Windows Library from Borland. All those languages can be picked at the very end, and that code can be generated.
Miles, thank you very much. I think this is a tool that most offices and organizations will have to deal with in the future.
Okay, thank you.
At this time, we'd like you to call in and ask questions of Miles, Barry, or myself regarding this product. Please call in now.
Reynolds, I really liked Protoview. That really was an exciting product. Miles, thanks for showing us that. That really, I think, was an exciting opportunity. I know myself where we have a lot of legacy systems out there, a lot of COBOL-intensive applications out there. This seems like a really good way to rapidly develop applications in any kind of environment. How long does it take to actually get up to speed on a product like this?
Well, if you take it and use it on your own, you can get up to speed in a couple of weeks. If you get our training, you could be productive literally after a couple of days of training, within that weekend. So you can do it pretty quickly.
In these kinds of products, there's probably a wide range of applications that you can develop. That's something that is very simple and something that is extremely complex. Is that your sense of how?
That's true. It's a very flexible tool. It allows you to build applications. It might just be client applications, simply looking at data that's right on the client machine. Maybe the application does calculations, does some amortization tables, and you can use it to build very complex applications like we've done for some major airlines, rental car companies, the stock exchange, and then the Conrail example where they had a lot of data they needed to access and to create the waybills that we had talked about during the demonstration.
So what you're really saying is, if I have like a local area network, let's take that as the first example, we can develop an application using some of the software that we already have, spreadsheets and databases that we already have in-house.
That's true, because our product follows some of the specifications by Microsoft, the Dynamic Data Exchange known as DDE, the Object Linking and Embedding OLE, and we can tie into those products. So the companies today are offering the suites, the Microsoft suites, the Lotus suites, and our product works side by side with those.
Anna from Silver Spring has just raised a question. And Anna, could we hear from you now, please?
Sure. My question, I actually have a couple of questions. I can see the application of this, application. This is really for application development and maintenance, it seems primarily. Is that correct?
This is for creating your application from scratch.
Right.
What we do is we generate code after your prototype has been completed, and the code we generate has a feature called code regeneration technology. What you do as a developer is you place your user code in between certain markers in the code that we generate, and then you can go back and modify your interface, change the prototype, add dialogues, take away dialogues, change the linking, and regenerate the application, and we will protect whatever code that you added. So the regeneration technology allows our product to be a work in process from conceptualization to the design to the beginning of your application prototype all the way to the final binary executable, because we work hand in hand with popular compilers that are on the market.
But if I'm not a developer, what difference does it make to me as an end user who wants to use what's developed, but I don't care how it got there?
Well, our product is specifically for the IES community. It is for developers. It is for IMS departments to take and build the applications that are going to be distributed in the organization for end users. So.
Okay. Well, all right. So I can see how the client server can replace the mainframe or certainly move the mainframe out of the spotlight. What kind of impact is this going to have on supercomputing?
Supercomputing really at this point is not in the same game what we're dealing with. We have a product that lets you build applications to take advantage of really the cheap microprocessors. The supercomputing type applications which do prediction of weather, whether tornadoes are going to appear in certain locations, that's really in a whole different ballgame to what we deal with.
Yeah, I work for an organization that does tremendous amounts of data crunching, and so we have supercomputer as well as lots of mainframes, and we're moving into the client-server environment.
Right. At this point, the client server and the microprocessors that are utilized really don't compare to machines like the Craze and the thinking machines, Connection 5 machine. Our application is targeted mainly for developing the internal applications for organizations like Conrail and developing client-server applications that do order processing, inventory management, and those type of applications.
Okay, I have lots more questions, but I'll give someone else a chance. Thanks.
Okay, thanks.
Miles, one thing I'd like to talk about just briefly is when you talk about client-server, some of the processing gets done on the client side, on the PC side.
That's correct.
But you can also issue the SQL commands to do a lot of the crunching on the mainframe side.
That's correct. Our product, it interacts with ODBC, a specification by Microsoft, and it interacts with Q+E library, a product from Q+E software. And what those products are is they're middleware libraries, and those particular libraries can be used to access the relational databases on the market. Our product, SQL View, that I demonstrated, it visually wraps those particular products, and it allows us to either create forms, or using the data lens matrix, we can query data in tables. But you have the flexibility of using our API, which is the SQL View API, an application program interface, so that you can just put in generic SQL statements and actually issue statements to allow you to access stored procedures that reside on the database side.
So I guess what the point I'm trying to make here is not all your processing happens on the client side, even that's where you're running the application. Right. A lot of the horses that are running can actually occur on the mainframes out there. So a lot of the crunching, like doing a payroll application, isn't done on the client side. Yeah. The processing itself would be done on the server side.
That's correct. We can take advantage of really accessing data that had been put together and constructed from a stored procedure that was kicked off by some trigger. Our application can make that trigger kick that stored procedure off.
I'm just wondering in a way if, as a result of all this, that we're going to change the way in which programming takes place. Is this the beginning of a whole new era of programming?
Certainly it is. The visual programming techniques that have just become available in the last couple of years is really going to change the way we think about application development, and especially with the object-oriented technology that's on the horizon. Our product works with the Microsoft Foundation classes and the Object Windows Library from Borland, two very popular class libraries that can allow you to quickly generate your application prototypes. And it's really getting to the point now where the application developer in the organization can sit down with his end users and say, do you like the look and feel of this particular dialog box? If not, let's change it, let's query the data, and really look at the integrity of the data before the final application is ever put out into the field.
Well, that's the whole key to this whole type of product, is the rapid application development, and that's what we've sorely been missing throughout the years of the mainframe-oriented application development processes.
Right.
You know, Barry, I'm wondering in a way if what we better do when we look at this kind of product is look for the long-term cost-effectiveness of doing it compared to just what it's going to cost to continue to carry on standard-type programming. And when you put those two sets of figures together, there's no way that you will continue in the long-term standard programming process.
Well, also there's a very short segment of code that you actually have to maintain. It's all the rest of it is generated code, so you really don't have to maintain all that code. It's a very, very small subset that you maintain from now on.
That's correct.
Yeah. Miles, thank you very much for this excellent presentation.
Okay, you're welcome.
started a couple of years ago. Aly, I believe it was just about 2 years ago this month when we began to talk about the idea of the kinds of problems that there are in higher education that we really needed to look at. And we said that it seemed to be a national tragedy that so many students in the United States were going to school and were failing the first year. And out of that came an idea that perhaps there could be a program, a choice model, a decision support system that you could develop that would really allow these colleges and universities to do a better job of predicting the success or failure of undergraduate students. I'm sure you remember the discussion. How did this, what did you then begin to think about as you put this whole model together?
When we first started, that was 2 years ago, as you mentioned, we looked at some artificial intelligence packages, and we discovered that we need to develop a model in order to use those packages. And the existing simple or conventional statistical packages were not at all supportive with the artificial intelligence packages that were available in the market at the time. We interviewed 2 of the software companies, and we decided at that time that we need a rigorous model that would be developed mathematically using the technology available and using rigorous mathematical and statistical equations to be able to give the best predictability for the retention of students within the higher education institutions in general. To do so, I had to go through some of the existing models for decision making, and those what we call choice models or mathematically developed choice models were used extensively in the field of transportation, especially the University of Berkeley in California had several papers written in that endeavor. In my model, I concentrated on some of those models that are already available.
Mm-hmm.
And what encouraged me very much is that in the past 2 years or so, during the recession, which we are still in the tail of it, most of the airline companies went to use similar or develop similar models in order to stay in the market and be able to face the competition, which was very high and still is. So from that point, I went on to study some of those models. The basic 2 models I concentrated on were the Probit model, which is shown in exhibition 28, where it shows a normal distribution model.
Mm-hmm.
And this was extensively used in the field of transportation.
Okay.
In exhibition 29, in exhibit 29, we can see the logit curve, which is exponential distribution function, and it is independent identical distribution curve. And in this curve, it seemed to be more practical and more realistic than the Probit curve. I didn't have any preference to start with, but I thought that this was something new that was not applied to that extent and does not have enough documentation. We have to realize that a lot of the airline companies and even the WMATA of Washington Metropolitan Area Transit Authority are not exposing what they are developing for competition reasons and the like. So we really don't know what exactly they are using. But we do know that they are using choice models, and we know for a fact that they are developing it specifically for their usage. In Exhibit 30 and 31, we can see the equations of the probability functions of those 2 models. And one of the reasons really I ruled out the Probit model, or I thought it might be more complicated for usage, is that although it's a normal distribution, it has parameters that are hard to calculate, and any degree of error in calculating the parameters would lead to a big error in predicting the probabilities at the end. So I tended to use the logit function because it was easier to predict the parameters of that function, which is in Exhibit 31. Exhibit 32 shows actually the utility function of any choice model, which is equal to a choice function plus an error. The challenge that we had is to maximize our choice function and to minimize our error. And in doing so, I went through a lot of derivations, and we were able to come with a logit model specifically developed and derived for the higher education institutions, with all the constraints and the limitations and the restrictions involved. In finding or in building the computer program to prove the applicability of that model, we tried to get some data, and the George Washington University School of Engineering was very courteous to us to give us most of the data that we asked for.
And we asked for data that would allow us to determine whether or not the model would predict retention. Is that correct?
Exactly.
Okay.
And there are minor data that they weren't able to supply us with. In Exhibit 33 and 34, we can see the data requested, and some of those data, the model itself or the program itself was able to determine which is significant and which was used for just the data classification. In essence, the scenarios that we used
In other words, you're saying that what we were able to do is to identify those particular variables that would make a difference in the prediction process.
Exactly.
Okay.
Exactly. In Exhibits 35 through 38 shows the result of the program that was run on that model, and it shows only 4 scenarios out of 10 scenarios that we had. And in those scenarios, we get the program predictive probability to continue for certain group of students. Like in Exhibit 35, for example, we have the American white females with high SAT scores, and the model was able to predict 70.72, or let's say 73%, whereas the actual figure was 66.67 or 66.7 approximately. And that was a very good result to get out of the program, and that was the first run without any artificial intelligence involved.
In other words, what you're saying is that that particular variable is a high predictor. Is that what you're saying?
Exactly, exactly. We got from the program of the model, the predictive probabilities were given to us, and those predictive probabilities, when compared with the actual figures that we had in college, as we can see in Exhibit 37, for example, and Exhibit 38, we can see the difference was within the range of 4% or less.
So it's a very high predictor.
It is a very high predictor. Over and above, the model is built to incorporate in the future any historical data in order to minimize the error or converge the error even further and further.
Well, Ali, let me then ask a couple specific questions
Sure.
before we come to the students. In this particular tool that you put together, you'll be able to use this in any college or university, correct?
Yes.
Okay, and depending on the data that's provided by that, you'll be able to help that school determine what are the predictor variables.
Exactly.
Okay.
Exactly.
The third point is you'll be able to do it dynamically, because in your particular model, as the data is fed in, the model in effect learns.
This is very true, and you raised a very important point, is the fact that we are using more than one variable at the same time. This model used a very a special case of the multinomial, what's known as the multinomial models, and we used two variables changing at the same time because this is the real world where variables change simultaneously. Previous statistical packages are using one variable at a time and disregarding the other variables or assuming that they're fixed or constants, which really doesn't give the real world variations. This model is including, exactly like the transportation models, we are including several variables going together.
How does artificial intelligence play into this model?
Artificial intelligence, in very simple words, is looping back previous results or historical results in order to improve new results.
Mm-hmm.
In this case, we don't have an artificial intelligence package so far, but we are using a looping back, an artificial intelligence technique known as the adaptive intelligence or the like. We are looping back the results that we get from one run in order that in the following run it will affect us with the same degree of weight that it had in the previous run.
So it learns, Barry.
Mm-hmm. Well, it sounds like a complex process that you've got there. How did you decide what technology to apply to it to solve that problem?
Well, this was really taken by a lot of interviews that we had with the engineering school at George Washington University, and we had with the operations research department, with the mechanical engineering department. And from my background as a simulation engineer, I worked in power plants, and I was exposed to a lot of sophisticated softwares that really benefited me in developing this model specifically.
I'd like to sort of summarize in a sense before we have the questions. And
But we're going to encourage the students to call in if they have any questions
yes,
right now, please.
by all means, begin to call in as we do this. The key to this whole thing is that the model learns.
Mm-hmm.
The model can have any school, no matter where it is, be used in order to predict those specific variables for that specific school. It learns as it goes along. As new data goes in, Barry, it can continue to predict, and it predicts more precisely
Exactly.
all the time. So it's a real learning situation. Are there any other factors that you feel really need to be pointed out to our viewers, Aly, on this whole model?
I want to conclude by the fact that this model will not only increase the quality of the students in any higher education institution, but it will also increase the retention rate among the less qualified students within the school if preventive measures are taken for those students, and those students we know ahead of time that they need to be strengthened in such and such a background. It will also increase the qualified students as a whole in that institution, because we will recruit more qualified students and we will strengthen the background of the weaker students within the institution. In general, this model just opened a new field in the higher education institutions so that we can apply more mathematical choice models. We can use more mathematical tools. We can have more precision in the decision making, and we can use automated means like the artificial or adaptive intelligences. This can be used also in firms outside the higher education institutions to train the employees. And as a matter of fact, I was approached with a consulting firm that they have a kind of a contract with one of the gigantic companies in the United States, and they are considering the model in order to cut on the expenses of training their employees.
Absolutely.
And I made just a small presentation to them. It can be used also in other disciplines like product optimization, feasibility studies, minimize high school dropouts by rechanneling high school students whom we know early on that they will drop out because they belong to a certain group, and they have a high predictive probability in that area.
Well, I'm also thinking it could be used in how successful you're going to be in whatever job you're going to go into.
Exactly.
If you want to generalize it, yes,
Yeah.
definitely.
We would like to have the students ask questions at this time, and I know that the presentation in part was a little technical, but it also has some very critical implications for the entire field of education. So by all means, please ask your questions. Aly, how long would it take a college or university to really put this model online and make it work? Make it work really effectively?
I think that it can take anywhere from 2 months to up to maybe 3 months. Because first of all, in order to make sure that this model works for a higher education institution, we have to make sure that all the limitations and the restrictions within that institution is taken into consideration.
Okay.
Secondly, we have to scan the data and make sure that the significant data is taken, and all the classified data that we need are also available. In some institutions that I've been to, data was not available, or we had a really hard time to obtain any data, any significant data, if I may call it. Categorical data or significant data is a major need for such a model to be developed.
Mm-hmm.
This model needs very little training for the administrators or the MIS departments in any higher education institution, because all what it needs is to interact with the model by giving it the right data, or the model itself will sort out the data, but we have to know that the data being given in is read correctly by the model. And I don't think it should take more than maybe 2 to 3 months maximum.
Aly, we have a call now from Denver, Colorado.
Okay.
It's Vicki Sear, who works in a school system in Denver. Vicki, can you hear us?
Yes, I can.
All right, would you please ask your question of Aly?
Well, good evening. This is a very interesting proposition here, and one that presents both possibilities and possibly some dangerous effects, I think, in terms of the higher education institutions. I work with a very high-risk population in an elementary setting. My guess is that they will also be high-risk in many respects as they go on. And I'm just wondering, how can we be sure that such a tool as this will not be used to further discriminate and put up barriers against the student that's already at risk?
It's a good question, Aly, right?
Yeah.
When you say that it will enable an institution to help students prevent them from failing, how can we ensure that they will in fact build those kinds of programs to help students increase the probability of success rather than putting up another barrier to increase their probability of failure?
I got your point, and thank you for that question. It's a very good question, and I took that into consideration. In marketing for this model, we will make sure with legal terms that this model will not be abused. Any tool can be used in the right direction or the wrong direction. The nuclear power, for example, could be used to produce electricity, or can be used to destroy cities and nations. But this tool, of course, can be abused, and can be abused to discriminate against students, as you just mentioned. And we will make sure that it is not abused in any contract that we write with any higher education institution. We are education specialists before anything, and we are against any kind of discrimination, whatever it is. And in doing so, we will not enhance the failure of students. On the contrary, this model will predict early on the students that have certain weaknesses, and we will be able to handle that matter before the student would be compelled to leave the school for one reason or the other, or put on probation or what have you.
Okay.
Well, yeah, I think what you're saying is it's a tool that we can use to make them more successful.
Exactly, exactly. I mean, if we can modify it to that, in that direction.
Yeah.
In essence, let's give a very simple example. Like physics, in college physics, is known to be a hard course for most of the students. If we know for a fact that students cannot go through that course easily, and we know that there is only a certain percentage who can go through that course with no problems, we can split that course maybe to 2 courses or 3 courses without any financial burden on the student by lessening the credit hours or distributing the 6 credit hours on the physics courses to 4 courses. Let's say the first 2 courses would be 1 credit hour each, and the second 2 courses would be 2 credit hours each. And the students going through those courses will strengthen their background if they don't have already a good background in physics from high school, and would make them go through the college much easier and would lessen their dropout or leaving the school for that reason.
Okay, let's take another question right now. We have a call in now from Elaine Marcucci from Blackwood, New Jersey. Okay, Elaine?
Hello.
Hi. What is your question,
well-
Elaine?
Excuse me?
What is your question, please?
Oh, I'm sorry. I guess my concern is very similar to Vicky's. Are we going to try and discourage those students that we feel might not be as successful in school? And for instance, I didn't do very well on my SATs. I'm not a very good test taker, but yet I did very well in college. And I don't know how you would be able to tell from your model that I would be successful in school because I didn't do very well on my SATs.
Well, the SAT was only an example taken to verify that model. It wasn't, and it's definitely one of the significant variables that the model chose because of the limited data that we got from the School of Engineering. The data we requested that you saw in exhibit, exhibits 33 and 34 were just we did not get all that data. We got only a portion of that data. But we took that data just to verify our model and to validate the program that was built for the model. It's by no means to discourage students from applying to a school. It's only that the school will recruit students from certain categories, if I may call them, or with certain scenarios more than others. And all students who apply to a college are taken today because colleges have a problem in recruiting students, not the opposite, throughout the United States as a general rule. But those students who will enter school, and we know for a fact that throughout their college years they might face a problem, we will early on say, oh, those students need certain prerequisites in order to be able to get along. And they can go through certain programs. They can, the whole syllabus can be changed in order to adapt those students. This model was built in order to raise the standard of students within a certain institution. It's by no means to like repel students from higher education institutions. We are trying to recruit students to higher education institutions, not vice versa.
Well, I hope that really addresses the issue. I think they're raising some pretty important questions, aren't they?
Yeah, yeah. And I thought of those questions partially when I was developing the model. And I made sure that when marketing for this model, we will not allow any higher education institution to abuse this model. The license will not allow them to do that.
So you're going to have a monitor on that really controls that kind of factor, and that's really, and that has to be.
Yeah, yeah. We will support the model for a long period of time.
Thank you. Really appreciate it.
There are no more questions.
The implications, though, were really...
Well, in the computer field is training.
Throughout this entire show, we've been concerned about just how costly and how effective the whole training cycle is within the overall development process. Today, we have with us Bob Shea, the CEO of Insync Corporation, who has developed one of the most important training tools using multimedia that we've seen. Bob, in this entire training process that you've put together for corporations and for higher education and government, I guess just about every field that there is, you've centered on putting together multimedia as a training base, and you've also picked a very, very important topic at this point in history, which is total quality management. Can you talk a little bit to us and give us a demo on what the logic was in putting this together in your corporation?
Yeah, I think we were very mindful of some of the traditional problems with corporate education. The primary one, I think, being the learning degradation that occurs between the advent of the learning and the application of the learning on the job. So we wanted to use multimedia to shorten that time, in some cases eliminate that time frame between learning and application by bringing the learning event closer to application through just-in-time techniques. Multimedia allows you to do that. It allows you to do some other things that are natural to the process and to the media. It allows you to reinforce training. The reinforcement of training through the use of multiple media, text, graphics, video or animation, and sound, particularly audio, is an excellent way to both engage the student or the user and to sustain his interest. I think those were the primary goals, to increase retention and to shorten the span between the time of learning and the time of application.
Also, you've added a very important feature, and that is you've been able to incorporate particular companies or universities' own personal interests and applications directly within your software. Have you found that to be very helpful when you deal in the corporate level?
Yes, I think this technology is best when it is customized to a particular industry, more so perhaps to a particular company, and even further to a particular application. The production of a generic multimedia title provides the framework to do that, but most organizations find that they want some changes to that generic title to reflect more precisely their terminology, their applications. But we've found that the use of those applications and technologies adds credibility to the final product. So I think one of the characteristics of multimedia, which is very, very important, is that it does more closely simulate the workplace. Because of the way it's produced and the timing and the involvement of the users in the production process and the use of these multiple media, you can in fact simulate the workplace much more effectively than you can with traditional classroom training.
Also, there's another piece of this from what I understand, and that is that it has a number of feedback loops in it, so that as a person is getting training, and if they happen to take a path that's not the best one to learn, that it actually feeds into their training and corrects the situation or corrects their logic.
Yeah, I'm glad you mentioned that, Reynolds, because it is a further very, very important aspect of the technology and of the program, and I'll demonstrate that to you in a moment if you'd like. The ability of the user to browse through the program, to navigate through the program, if you will, to select those items that are of immediate need or immediate interest is a very, very important aspect of sustaining his interest and of giving the user a sense of empowerment in terms of learning what he needs to learn in order to do an effective job in the workplace.
You know, Bob, we've been very, very concerned about the total cost of training as an integral part of the whole process of improving productivity. And this has been the theme, really, of the whole show. This may be a very important point in helping people to really understand how this type of training can improve productivity and in the long term really decrease the overall training cost.
Mhm.
So I think these two factors are really important. Could we take a look and just see one piece of your show and see how it works now?
Sure. I'd be glad to do that. On the subject of cost, I might mention that there was a study done, I think a couple of years ago by the Institute for Defense Analysis, and they showed a 64% reduction in the cost of multimedia training versus the cost of traditional training when you factor in the development cost as well as the maintenance cost as well as the delivery cost. And it's in that area of delivery cost in particular that multimedia training really shines, because the equipment cost, the platform on which this training is conducted, whether it's used as an instructor aid or used as a self-study vehicle, the platform costs have come down so substantially, and they've been so miniaturized that you in effect have a portable classroom, which dramatically increases the accessibility to the training and brings it, as I mentioned, closer to the advent of the use of the training in the workplace.
Well, I guess there's just one more point before we do the demo, and that is that people in the United States are very mobile.
Mm-hmm.
They move around.
Mm-hmm.
And so the concept of training is not one where you bring a group together in the classroom and you train them and that's the end of it.
Mm-hmm.
You've got new people coming in, and they have to be trained equally in order to perform effectively in their jobs.
Right.
And one of the key aspects of Insync development and logic is to provide for that gap when new people do come in. So you don't have to have all the people come in all over again. You can provide the training. In fact, you could even upgrade the examples, from what I understand.
Absolutely, yeah.
So you constantly keep it up to date for that corporation or for that university or educational institution.
Mm-hmm. Yeah.
Let's take a look
exactly right.
at
Yeah,
your model.
we both develop multimedia and we market the best multimedia that we can find in the marketplace. This particular program on TQM was developed by Micromentor of Cambridge, Massachusetts, and it's marketed and supported by Insync. Let's just take a look at some of the features that we spoke about, particularly...
The process improvement cycle is based on Dr. W. Edwards Deming's famous Plan, Do, Check, Act cycle, which embodies this pioneering thinker's belief that continuously and systematically market testing, redesigning, and improving our products and services is the best way to meet our customers' needs.
To learn more about each of the stages in the process improvement cycle, click on the diagram. It's a good idea to go in order, beginning with the first stage.
See, particularly I was going to say the ability to navigate through the program. I don't have to start with the first stage. If I've been through that, perhaps I went through the first and second stage the last time I used the computer. So I can move, if I choose, to the third stage.
In the third stage of the TQM process improvement cycle, you'll begin by planning and then running a pilot implementation of the proposed
Additionally, I
process
can
improvement to check whether it actually
pause at
works.
any point in time. I can move up to a glossary, for example, if I encounter terminology that I'm not familiar with. I can leaf through that glossary, find the definition of a term, and then click on that term and have it defined for me, and then return to the program.
That's excellent.
I can resume the program.
During the pilot, your team will measure the new output of
I
the
can
improved
skip
process
this
to make
aspect
sure
of the
that
program
improvement
if I
has
choose.
Click on any of the steps in this stage.
I
to
can
learn
go
more,
further
or click the
on a
done
layered
button to
basis.
return
I can
to
go
the
as
four
deep as I
stages of the
choose
process
into
improvement
any
cycle.
stage.
As your team runs the pilot implementation of the proposed process improvement, you need to make sure that the solution you've implemented actually removes the problem and results in higher quality output. You'll collect data to compare performance before and after implementing the solution. TQM tools that may be helpful to you and your team at this point in the cycle are listed on the screen.
Now, if I'm not familiar with those tools, I can pull down a tools menu.
Oh, interesting. Well, let's take a look at one of the tools. How about cause and effect diagram?
Sure.
A cause and effect chart, also known as a fishbone or Ishikawa chart, is used to visually represent and identify the possible causes of problems in order to find the root cause.
Again, I can go as deep into the program as I choose to by clicking on the illustration. I can see a
The
demonstration.
problem identified,
of
unproductive
that particular
meetings,
tool.
is placed in the box at the right of the diagram. The areas selected as main factors causing the problem are boxed above and below the center line. In this example, they include environment, procedures, resources, people, and communication.
So I think you can see, Reynolds, that the program allows the user to navigate, to move back and forward through the program, to move to those areas that are pertinent to his immediate needs.
It seems to me that no matter what the person's particular learning style, that it doesn't really matter. They can go in and out. They can, if they don't understand what environment really means, if they don't understand what resources really means, that they can actually go in, look at it. They can look at the glossary if they want to see what the definition of terms is, and concentrate on that until they're absolutely sure. Plus, you've given them the capacity to track all of the components to understand the overall concept that's involved.
That's precisely right.
It's a pretty good tool.
Yeah, we've found that the companies that are using it are showing very measurable results in terms of improved training effectiveness. And that's another cost that isn't often considered, and that is the performance cost of training. In other words, what effect has training had on the actual performance of the individual or the organization? We think that this contributes to much, much higher performance.
I'd like to just go over a couple of the points that I've seen here and make sure that I understand them. A person, there seem to be 3 or 4 different levels. Okay, a person can go into those levels one at a time, in or out of the levels. So you go from a very generalized conceptual level, and you can then take, each concept is illustrated. Each concept has supporting explanations at each level, correct? Okay. Then you can go beyond that. If, for example, I wanted to see something about the word environment, and I didn't exactly understand how environment fit into the concept of unproductive meetings, then I could go into there and look at what environment is and what it's about. And that would lead me verbally, it would lead me from a pictorial or graphics point of view, precisely to understand what was the cause and effect relationship of that whole concept. Do I understand that?
That's correct, yeah. Yeah, and that, I didn't demonstrate it, but if it's a word in common use within, in this case, total quality management, you can type that word in, and the chances are that the glossary will find it in the dictionary and display the meaning.
Is this, as we go through total quality management, as I understand again, it's a person can go from concept to concept, or within each concept, in order to understand every single element. And is there a point in here where you can measure whether or not the person understands what is being presented?
Yeah, there are 2 tests, we call them tests, they're not really, they're games built into the program, which allow you to test the individual's knowledge in a game format. It uses a Jeopardy kind of format to do that.
And does it actually have a way of determining how many rights or wrongs there are in those games?
It does while the person is playing the game. It does not, this particular program does not include student accounting, which would retain that data and make it available the next time the student uses the program. Although that type of addition to the program would not be difficult to add.
So not only do you have a baseline program, but you also have a way to customize it for a particular organization. You have all these reinforcement factors. You have at least 3 or 4 levels of conceptual and practical applications, all of which are supported by diagrams, graphics, in some cases moving graphics, and sound in order to put it all together.
That's right.
So you've taken all the reinforcement factors as well as the kind of visualizations people have in order to learn effectively, and you've put them into this one package.
That's right. The customization that most organizations want is they would like to have their CEO or managing director's image and message at the beginning of the program, and very frequently they would like to display some of the generic examples with specific examples from their organization or their industry.
I think as we move into the future, it's the power of this kind of concept and the illustration of the kind of tool that you have that's going to make an enormous difference in training through automation and improving the productivity. And Bob, thank you very much for this piece of it.
Thank you very much.
This is a pretty interesting tool. We would like at this time for you to raise your questions with us. Please call in And as you call in, I'm going to be asking Bob a question about something I saw in the tool that I felt was pretty important. Bob, if I understand it, you can actually build in a specific example from an educational institution or a business or industry or corporation that then would allow that organization to actually train the employees with the specific example from within the organization. Isn't that correct?
Yeah, it is. And as a matter of fact, you can take it a step further and link the educational program to an operating program, so that if you were, for example, discussing surveys, you not only could branch to an example of a survey process, but you could link the user to an operational survey program. Again, stressing the design goal of bringing the learning closer to the application.
Bob, if you could actually, in this particular case, help use the TQM process to actually find the problems and then build those problems directly back into the multimedia training program in order to correct them. Isn't that right?
Well, that's right. I mean, there are very few limits other than cost on how you can make this program or this type of program more relevant to the workplace. But essentially, by changing the material and customizing the material, you're making the program more relevant to the learner, and that's really the whole idea of multimedia.
And it doesn't matter if it's a corporation or an educational institution, a university. It applies to every single area, doesn't it?
Oh yes, absolutely. There are a lot of uses for multimedia beyond education, and a lot of people are using it for employee orientation, for sales presentations, sales support, for training customer service representatives, that type of thing.
What I really like about the product is it's got a generic model, and then you build your specific examples under it or into it, and you don't have to maintain the whole multimedia application, just the parts that you have in there. And that, I think, is more valuable than anything else, because it allows you to rapidly deploy something that the people can use.
Well, that's one of the great advantages, and one of the areas where development, of course, can be contained, because it can be a shorter period of time if you're to develop a program, a quicker reaction to an operational need for training, if you start with a core program that then can be customized to reflect the problem more precisely.
We have Ann from Silver Spring is going to ask us a question. Ann, can you ask your question of Bob?
This will be a quick question this time. I wanted to know who has to do the customizing. Is this something that I would buy and then I can put my own parts into it, or is it something that I have to do through you as my vendor?
I think there will come a time where you'll be able to develop or customize your own programs, but this program and most of the programs that are being developed currently, the developer does the customization. The distributor may help you with defining the areas of customization and the content and the cost, and even with the deployment of the program, but the developer would actually do the customization.
Well, that means that it isn't modifiable either without going back to the developer again.
Well, again, it depends on a number of factors. One is what is the medium that the product is being delivered on. If it's a CD-ROM, it's probably not going to be modifiable. If it is a product that is contained on the hard disk of the PC, then it's possible that you could negotiate with the developer to make your own changes to that program.
Oh, so this isn't necessarily a CD-ROM?
Not necessarily, no. The advantage of CD-ROM, of course, is that you've got much greater storage capacity, and you can incorporate even video to some limited extent. Full motion video in an abbreviated window. But the advantage of having it on a hard disk, if that isn't required, is that it's much more readily customizable, and the product platform, the platform on which the product is delivered, is also less expensive.
I have a video disc course that I use in my organization, and certainly the video disc is not changeable. However, I can go in and customize and add my own units, and that's the authoring capability is built in and that resides on the hard disk and makes it a very flexible package.
Yeah, I think the advantage of the current multimedia technology is that it can be deployed on a much less expensive platform than a platform that would include both analog and digital components such as video disc and the PC. So it's really a question of how much interactivity is required, how many people have to be trained in how many locations, and a number of other factors come into play in terms of choosing the technology for development.
Thank you.
Right.
Over time, this type of training could be used over and over again in the same institution. And they themselves, as they moved into it, could continue to upgrade and put new examples in order to solve the problems that they have. Isn't that what this is about?
Yeah, that's one of the things that we've done in each of the areas that we become involved with our customers in. We deliver a service or a product, but we also deliver a capability, and we transfer a technology over time so that the customer does develop this capability over time. And should he choose to go that path, then I think that the benefits of multimedia can be applied across his entire curriculum at considerable savings when you consider the development and, the deployment and maintenance cost in addition to the development cost.
Yeah, I would think if I was developing this type of training opportunity, what I would do is I would use the base product, and then I would build all my examples or my individual situations in there, and that's going to take a significant amount of my time. But after that, once I see a problem crop up here, then I don't have to modify it all over again. I just have to maybe add to or modify the way I'm approaching that particular area of the application. And that seems like a lot of time savings because I still have all that built-in investment I'd be able to reuse and reuse in most of the areas, but then I'd be able to customize and beef up in one area that I'd be able to train on.
The key for me in this whole process is that I could take my particular problems and I could build those problems in, and I could train people how to overcome the problems directly within the training package through games or whatever process is used. Isn't that correct, Bob, that you have a game scenario in there?
Yeah, there is. In this program, there is a full-blown game scenario using the Jeopardy format. Yeah.
What other kinds of applications would this kind of technology lend itself to?
As I mentioned, I think corporate presentations, the early adapters of this technology included Xerox and Federal Express, which used it for customer service training and presentations. And a lot of companies are using it for, they're employing it in kiosks to get their corporate message across in public places or to new employees or whatever. So I think corporate presentations is a major area of application, as is sales presentations.
But you were also talking about human resources, deploying it in that area for maybe more information on Family Medical Leave Act or ADA or some of the other areas out there that corporate-wide need to know about.
Yeah, I think the real strength of this technology is that it can take a complex topic and break it down into its component parts, and then allow the learner to approach it in a way that's most relevant to him, so that you no longer think in terms, or should think in terms, of a 40-hour course. You should think of a course which some people are going to get through in 10 hours and some people are going to take 60 hours. It depends on where they start from, it depends on their knowledge going into it, and it depends really on whether they want mastery of the topic or they want a general knowledge of the topic. So it serves both users equally well. And I think it can be applied in human resource areas as well as other more general training areas.
Well, that's the key, isn't it? Human resource development is really what this whole thing is about ultimately.
Well, and it approaches it at many different levels, which is another key. You don't have to just train at an executive level and then develop a separate one for a lower level. You can combine it all into one type of training opportunity.
It's meant to train the whole organization.
That's right. That's right.
And that's what it does real well. Well, I guess if I had to make one comment on it, I would have to say that I think that this tool is a development tool that corporations, educational institutions, and agencies have to take into consideration. And I think Insync has really done a great job, Bob, and you have as its CEO.
Thank you very much.
Barry, we've seen some really great tools tonight. Development tools that are going to make a big difference in what the future of automation and improving productivity is really all about. What kinds of things did you see that you really felt would be at the top of the scale in development?
Probably the two things that impressed me very, very much about the products that we saw tonight were really two things. One was that you could rapidly deploy products, whether they be applications or training opportunities, to the end users. And that really has probably been the biggest bottleneck in organizations throughout the country, is that it takes so long to do something because you had such program intensive or such a long time to create something. And what these developers are allowing us to do is to be able to rapidly deploy applications and training opportunities out to our users. The second thing I think that it's really doing is just providing it in a very user-oriented manner, very graphical environment that people are starting to become more and more familiar with, and getting more and more familiar with over time with the use of Windows. So they're putting them, not only rapidly deploying them, but they're putting them in environments that we're used to seeing and used to using, which is really neat.
I do have to comment on one thing that I saw, that I heard and saw tonight that was important, and that is our call-ins raised some pretty important ethical questions when Aly Monsour talked about his program. Incidentally, his program does work, and I believe it will open new doors for how colleges and universities select students. But Vicki Sear was really on target when she raised the question about just what would this really do to the disadvantaged students in the United States. And I thought Aly did a great job in saying that they would have to sign a contract at taking care of that very, very important ethical consideration.
Well, the point is that it is a tool that took some complex concepts and was developed using technology to assist in the learning process. And I think that that's really the key. Is it's designed to be a tool to assist and support in the learning process. But is really even more amazing is it was able to take those complex processes, just like Protoview was doing with complex programming processes, and Bob was talking about with the training opportunities. It takes complex processes and breaks it down and presents it to the user in a very easy-to-use type of opportunity.
When we started this show, we talked about making sure that we would not solve complex problems with simple tools. I think we saw some very, very complex tools tonight that handled very important strategies and processes in very simple ways.
Well, that's the key. It's not the complexity of the tool that you're using, although it helps to have something that's easy to use. But it's the end result. It's the output that goes to the user. If the user perceives it as easy to use and very effective in their use, then they're going to go ahead and use it in their environment.
One of the things that when Bob Shea presented his tool that I felt was very important for us to consider in any kind of tool development of that type was the idea that you could apply all sorts of dimensions and strategies to training. A person could hear, they could see a model, in some cases a moving model, you could actually see the movement. It would be supported by text. It was done on different levels.
Well, and that's really the very interesting part about the way technology has expanded over the last year or two, is it is approaching it at so many different angles and at so many different levels. And you're able to develop a product or a tool that that gets at it from all those different angles and levels. And so you really have a lot of different products in one single application. You can approach it from the executive level, from the very lowest level, breaking it apart, putting it back together, and that's really useful when you want to try and train someone how to use a concept such as TQM.
I think in all the tools that we had tonight, we saw the beginnings of what every type of tool has to take into consideration. It has to train the whole organization.
Mm-hmm.
It has to provide the kinds of software, if it writes software, that will impact every phase of what you're trying to do, and it has to do it simply. You know, Barry, we can no longer afford to pay the money that we're paying to do hardcore programming, line-by-line programming. It just doesn't work.
Well, we don't have the time. There's such a backlog now, and the maintenance of all that code, whether it's training code or programming code, is just getting too expensive and too time-consuming.
So we have to have these tools.
Mm-hmm.
Now, I realize we only covered a few tools tonight, and there are hundreds of tools. We talked about this before, but we picked 3 illustrations and 3 tools that we thought would really make a difference in terms of the future of automation and would, in fact, really improve productivity.
Well, the key here is to get the students to think, you know, if these kinds of tools exist, then what other kinds of tools out there can you take advantage of to solve your business problems?
I guess that's it. And Barry, thank you very much.
Thank you.